Right on. While you're set up, I'll start the recording so we could segue straight into the lesson after this. I believe there were a few more of you that got some code generated. Kasia, is that how you pronounce your name?
Atia? Very
Katia,
close, very close.
very close, right on. You had some code, right?
Yes, I also asked it to generate some code for that very same problem that we were just talking about the 4x4 grid game.
Did it work?
It did work. It didn't exactly, I didn't keep going back and forth with ChatGPT to try to get it to output exactly the 4x4 grid. It turned out to be a 2x2 grid, but it did output some code that I was able to run on the browser, and it was pretty close.
Cool. If it's not going to take too long, do you want to share your screen and walk us through it?
Sure.
If feel free, I think if you share your screen, it should take over. If not, I'll stop sharing.
Okay. I'm gonna just grab it really quick.
While we're waiting on Charles and Katia, does anybody have any feedback on the lesson? Like, is there anything that you think could be improved or changed? Was there anything that was unclear?
I have one. Um, so I know that what I've seen so far in class is that, we do like a lecture and then we are, doing breakout sessions. Um, I think like maybe for like future cohorts, after everybody does the challenges, everybody does the well, pretty much for the challenges, I don't know if it's possible to have like the instructors do or upload a step by step of how to like do everything after everything is finished. So like once everybody's completely finished, to do a video of the instructors, doing like, hey, this is what I would do. This is how I would do it.
Sure. So every instructor kind of has their own style. My style is I like to have everybody reconvene at the end of the day, and I actually ask the students to volunteer their answers. And if it's a particularly challenging challenge where nobody was able to get it quite right, then I'll share the solution I had. But definitely, that's how I like to do it. If we get to a point where we get to a challenge where we're still not able to do that by the end of the day, just Slack me and I'll try to provide what I can.
All right, I think I got it shared if it's visible.
Cool. Let me stop sharing just in case it's, yeah.
Yeah. You see it?
Mm-hmm.
So it works, just along those lines.
Interesting.
It took me about 4 to 5 prompts to get it to work.
Can you share the code?
Yeah, give me 1 second and I will. Let me go back to stand by. I have an awful lot of windows, unfortunately.
If you want, actually, I can show you all how to navigate GitHub a little more because everybody should be able to see everybody's solutions. If you go to GitHub, or you could walk us through the code right here too, because that'll be nice for everyone to see.
Right. Stand by. Let me just get out of this. I'm not as comfortable with this yet.
If you're looking for your file browser, it'll be that very first button on the left.
There we go.
Okay, cool.
Sorry, you guys had to get out of that. Okay, so this is what it looks like roughly.
Cool. You want to take a stab at talking through it?
I'll do my best. To be honest with you, I have very little background in HTML. This was me letting the machine drop significantly, but the things that I inserted, so first it had to load 3JS, whatever, because that's what allows it to make the grid. I don't know why, but it does. And then right here was what it had me insert to make the mouse click work, because the first time I was doing it, it wasn't really reading a mouse click. So I think that's what this does here. And then down here, this outlines the grid. And then what colors it selects when you click on it. And then let's see. And this right here is, I think, what actually makes it run when you run it. But this bit over here, I'm not as comfortable with, like the fineries of what it does. That's just my best guess.
Mhm. Right on.
It's interesting it used Three.js instead of a canvas. Like you used a
Well, I asked it
library
to.
instead of just
I asked it to specifically. Yeah, I think it was in the prompt recommendation.
Yeah, that
oh,
was
gotcha.
yeah, that was a hint that I put. You could definitely do it with Canvas. You could do it with P3, all sorts of stuff. Like there's more than one ways to skin a cat. I chose to mention Three.js because I'm also working on a new set of lessons for the React portion of the cohort where I don't know if anybody here is interested in game design, but it's something that we haven't taught yet. So I'm writing some new lessons on using Three.js, React 3 Fiber to build out a game in React for your browser. Let's see. Katia, are you ready?
Yes, let me go ahead and share now.
Cool.
Okay, I have the code on the right side and then the browser little game that it generated. Essentially, the way that it works, I specifically asked ChatGPT to generate a game that worked through keyboard keys. So basically, right now I'm pressing the left side arrow, and now I'm pressing the right side down and then left again. And then this is, I'm a little bit lost with the the Zoom screen as well.
I see. I think
Okay,
start on 3.
here we go.
Okay.
Oh yeah. So basically I was thinking about some of the guidelines that we learned about telling ChatGPT like this is your role. So I basically told it that they're working on a browser-based city game. Well, the player can navigate a 4x4 grid using their keyboard. And I asked them to provide HTML, CSS, and JavaScript code to implement the functionality. And then essentially, I didn't really read in depth how the code works, but my understanding is that this would be the HTML portion where a grid is created. Here, creating a 4x4 grid. And then there is a listener with the JavaScript portion of it that is paying attention basically to the keystrokes that are being input by the user and gives it the functionality of like if it's pressing arrow up, then this is what will happen, and so on and so forth, depending on the key that is being pressed.
Awesome. Right on. Do you want to take a stab at explaining the function animate code block?
Which line would that be?
Starting on 456.
.406?
Sorry, 456.
Oh, 56 all the way down. So here it would be, my understanding, it would be essentially calling request animation frame, which I'm trying to see if this is a function that ChatGPT created, but it looks like it might be part of the Three.js library.
Okay. And what is it passing in exactly?
Animate. Yeah, I'm not sure. I'm trying to see if there is an object or a variable animate, but on quick glance, I can't find one.
Yeah, I think you're on the right track. I'm going to look up right now, request animation frame. So it looks like this method is, like you said, you're correct. It is a built-in 3JS. Actually, no, not just 3JS. It's just a standard web API. So this is being called by the browser and it's just accepting back. Do you have oh, it's calling itself. It's a recursive loop. It's just recursively calling itself.
Oh, it's okay. I
So
wasn't sure if that would be possible. Okay, so it's recursive.
So that's how it's able to essentially render, that's how it's rendering its listener and the reaction to the listener. So awesome.
Is it recursive because it needs to be constantly listening for those keystrokes to be happening? Is that why it needs to be recursive?
Yeah, I believe that's how this code is working. If you look down at a few more lines, this should be like 460 if you scroll down a bit. We're actually calling that animate function at 461. So we call that animate function once in theory, and then it just continues to call itself.
How is it storing or saving its state?
That is a good question. It is happening all entirely within the browser, within the DOM. So all of this
Okay.
all of this is basically active memory. It's not being stored in a backend anywhere. It's all just being stored locally. So it only exists as long as this browser session exists. Cool. Any questions? Awesome. Great work, Katya. I'm going to take over. I'm going to share my screen again, and I'm going to walk through GitHub so you can all see where exactly you can view each other's comments and stuff. I just have a hard time telling which screen is the right one. Yeah, this should be it. Can you guys see my GitHub? Yep. Okay, let's go over to our curriculum. And if you go back to yesterday's lesson, you go back to week 1, day 2, scroll all the way down, go to our challenge. For those of you that made a pull request, you'll be able to see it here under pull requests. So maybe I'll actually back up a bit and talk more about GitHub at a general level. This right here is a repository. A repository is basically just a placeholder, a container for code. From the GitHub UI, you have access to the bulk of the code where you have a file navigation system to look through the different files and look at these scripts individually. And you could also raise issues. This may be something that you can get some practice using. If you see anything wrong with any of the challenges or the lessons, another option, instead of just sharing that feedback inside of the daily check-in form, is to actually raise an issue. And this is something that you'll essentially be doing anyway when you land your role. And it's something that is commonly used when working on open source projects that are publicly available. But what we want to look at right now are the pull requests. So everyone that made a pull request and pushed their changes, anyone here in this class should be able to see each other's work. So if we go to, whose example was it? I believe it was this example that had, yes, the grid test that Charles was first demonstrating. So if any of you are curious about each other's code, use this to review each other's code and also to review your own comments and review. So all of you should have comments on on, let's see, did I add comments to this one? If it was pushed later, I thought I add comments to everyone's.
I just pushed that today.
Okay, cool. I'll add a comment later. So if you look at this one, we should see a comment. Maybe not, maybe this was also pushed recently. Yes, there's one with a comment. You should all have, if you pushed it before noon today, you should have a comment reviewing your responses to the challenge. So that's GitHub. Any questions on GitHub?
So if we don't see our pull request right there, that means we did something wrong.
Yep, pretty much.
Oh, okay.
We'll
Whoops.
cover GitHub like repeatedly. I think one of the complaints with some of the previous cohorts is by the end of the cohort, some students weren't feeling like they had enough practice with GitHub. So we're actively trying to address that issue this cohort by getting into the habit of working through GitHub command line commands more and just explaining just the theory behind GitHub and the elements of GitHub and the GitHub command line. So if we go to my solution, I asked ChatGPT for best practices using GitHub CLI. And then I asked it to get really detailed. This is kind of like how I like to think about Git commits. You could think about changes in Git as existing in 3 phases. You have your initial, yes, Taufik, come on. Did I say that right? If you're speaking, you're muted.
Can you hear me?
Yeah, I can hear you now.
Okay, so I have a question regarding the pull request stuff. So let's say in case I fork the repo to my home personal GitHub account, you know, I push that code, I clone that nearly fork repo on my own local machine. You know, I make the changes, I push it back to the repo. Now, what I'm thinking of from my home background, I don't think it should create a pull request on another person repo, if I'm correct. Like it shouldn't show pull requests on, for example, on Foxtrot Platoon repository.
If you set the origin repository as your upstream or your origin, basically if you make it a remote connection, then you should be able to generate a pull request. Let's walk through it the way that I have here, and we can talk about that in a little more detail when we get to that part. I like to think about creating changes in GitHub as consisting of 3 phases. Your first phase is your initial environment setup. You only got to do this once whenever you're working on a new project. And that's when you fork the source repository or you create a new one. You clone your fork to your local machine. So now there's the original repository, there's your online fork that lives on GitHub, and then there's the clone on your local machine. Once you do that, you could set up remote origins. By default, the primary origin is going to be the repo that you create a source from. So I'm going to actually, we'll walk through this, and then I'll show you in my own terminal, my own command line, how this looks. But you also have the option of setting an upstream repository. And basically, this is standard practice where your origin is your fork and your upstream is the source. This way, you can quickly pull updates and changes made to the source repository with just a single command line command. Once you do that, then you're pretty much all set up. From there, whenever you make new changes, you want to get in the habit of always switching to a new branch. You don't want to be making changes on somebody else's branch, and you don't want to lose track of your changes by putting them all into the same branch. Especially if you've been given several different assignments, or let's say you have different tickets, different agile tickets that require different tasks. It's just easier to get in the habit of breaking out the requirements of each ticket into a separate branch. Once you've created your changes, you're going to use git add to add the files that you want to change. Then you run git commit to commit those changes. Basically, the commitment is I've added these files. I am no longer going to make any revisions. And then you push that to your origin branch. The command line should generate a URL for you to click on, which is what creates the pull request to the source repository. And then one last thing that we'll cover more in the future. I don't expect anybody to memorize this part right now, but when you have multiple commits, it could be difficult to review. It's easier to review somebody's changes when they're all on a single commit. So if, for example, we go back to this repository, we look at, let's say, who had multiple commits? 5 commits here. I, as the reviewer, have to click through these individually one by one to see all of the changes. So there's a really cool command called rebase that allows you to squash your commits all into one. And that's something that we'll cover more as you get more comfortable with GitHub. And from there, once you squash your commits, all of this will appear as one single commit. Whoever's reviewing it can see it all in just one go. I'm going to stop sharing right here. I'm going to switch over to my terminal so I could talk through it live. Any questions based off of that explanation?
Okay, so I think I went over this having the instructor explain it, but if we can practice this more, I mean, if you go step by step, this will sink in, I think.
For sure, for sure. Let's do that right now, actually. And this is why every challenge, this is kind of why the repository is designed the way that it is. All the challenges are on GitHub, so you could get the muscle memory down of forking, cloning, adding, committing, and pushing to GitHub whenever you're working on a challenge. Katia, what's your question?
Yeah, I'm not sure if you're going to get into it now when you're demoing your terminal, but I was just wondering if you could explain the concept of the upstream again, because I'm not quite sure that I got it.
Definitely, yeah. I'll go over that in a bit more
Thanks.
detail. So let me know if you could see this. You should be able to see this. Where should I, let's use this for example. So there's some really good commands that you should always memorize, git status being one of them. I don't have any changes. It tells me that my working tree is clean. If I were to type, this is one of my own aliases, GW, I can see a few things. I could see that I have, maybe this isn't the best example because this is just the origin. I have not set an upstream. So let me do that right now. I'm going to go back to the repository. I'm going to pull the source repository. I want to make sure I'm sharing my entire window so you can see all the steps. Desktop, yeah, let's do that. Okay, I'm going to share my whole desktop now, so let me know if the text is too small. But here, I am now in the primary repository. I'm no longer on my fork. I'm going to go over to code. This is the button, the big blue button that you go to whenever you want to copy a URL. Hit copy so you don't accidentally miss anything when you try to just mouse copy, highlight, copy, and going back to my terminal. I'm going to run a command saying git remote because I want to add a remote source, add upstream, and then I'm pasting the URL. Now, if I run my alias again, I could see that I have an origin repository and an upstream repository. So if I wanted to pull changes to my local fork, because let's say, sorry, my local clone, my clone of my fork, because somebody made changes and push them to the source, I could just run git fetch upstream and the branch name. And now it's pulling all of the branch history and the commit history, and it's saving it into my local clone. Similarly, I can run git pull upstream main, and that's going to pull the changes. It's only fast forwarding because there aren't really any changes to make. What this fast forward means is it's updating the hash of the commit I'm in to match the latest hash. Let me show you one more thing. This is a git, let's call it a git visualization. This is a visualization of the different branches. Every branch, every commit has its own little hash code. And we can see them in a linear format. The very initial commit is at the bottom. The next commit named init that was made is right above that. And this is the change where I added my solution as an example. This is where I merged into main from my fork. And this is into init can't push. I must have I did some kind of a merge here. I can't remember. It's like a few days ago now. But basically you could see the entire history of the changes in this command here. Let's go into my aliases so you could see exactly what this is. I called it a dog, I believe. This was actually one of the very first things I learned in my cohort. Somebody from a guest teacher came by and taught us about git log. It was super confusing. Everybody was confused, but it was cool. We basically got a command that we didn't know how to use then, but we learned how to use it over time. So this is the command. It's git log. If you do git log by itself, that's all it does. It just tells you what branches exist in text form. It's not very easy to read. There's a lot of characters and hashes. So if you pass in some flags, like a decorator, and a command to pass it in just one line, and a command to render it as a graph, then that's where we get this visualization. Did Guillermo cover aliases when you all were doing your foundational setup? Cool. We'll touch in on aliases from time to time. Maybe I'll share some other cool ones. I'm going to copy paste this into the Slack channel so we don't lose it. And yeah, for reference, it's going to be in the Foxtrot EW channel. And what should I say about this? This shows your commit history in a visual form. So that's that. I've shared it in Slack. Where were we? We are going over commits. Let me show you this process fresh from the very get-go. So let's change directory up one directory. Let's make a new directory that's not a Git directory. So I'm going to call this January 11th demo. I'm going to cd into this. Get into the habit of hitting tab to autocomplete. It's super useful. It saves a lot of time. And I'm going to do an ls to show that there's nothing in here. Now I can go back to my browser. I'm going to go to my fork, which I could access quickly from. Oh, that's right. That's why I had that second merge. I made my own. I made this repo on my account. And then I had to move it over to Foxtrot. So let me just go over to my source repository. They're not really linked right now, so I'm just going to paste into my URL. Oops. Prompt evolution. Now I'm going to hit the big blue button. I'm going to copy this URL, and we could see that if I were to type git clone and paste in my URL, it's going to clone my fork onto my local machine. Let's We can see that here with ls. So let's change directory into this repository. And let's type a git status. My branch is up to date with origin main. Maybe at this point I should also give you, because I always kind of forget the components of this alias. When I run git w or gw, it is, what it's actually doing is it's calling an echo to basically render some text. And then here's the exact command that we're looking for. Git remote dash VV. I believe the dash VV is for verbose something. And this is the command that will show you your remote URLs. I'm going to share this as well in Slack right now. Any questions on either of these two commands? Cool. This shows your remote URLs. Okay. What else? So I've just cloned my fork. It's now on my local machine. I've set my remote URLs. I'm pretty much good to go. I'm ready to go and make some changes. So if I were to, let's say, I'm gonna open up this README, and I don't know, let's just delete everything. I'm gonna save that. If I want to get status, it's gonna tell me that this file has been modified. So let's add this file to our commit. I'm gonna tab to autocomplete. I'm gonna get status again, and now we can see that it's green. This means it's been added, it's been staged, and it can be committed. If I'm sure I want to do this, then I'm going to hit git commit. I'm going to type -m because you always need to pass in a message, a name for the commit. I'm going to call it deleting everything. Let's run another git status, and we could see that my branch is now ahead of the origin by 1 commit. My local clone is ahead of my remote fork by 1 commit. If I refresh here, you could even see in the UI, actually, no, you can't. If I make my pull request first, then you'll be able to see in the UI. Let me do my git push. I'm gonna push into my origin. I didn't change branches. Shame on me. So git push origin main is what I'm going to run. And now my changes have been pushed. A URL has been generated. I can click on this, and GitHub is going to show me the changes that were made. I see that this README is now blank. If this was a separate repository, an upstream, and I was modifying a fork other than main, then this would have generated a link to create the pull request. But because I'm working within the same branch, within the same repository, it's just making that change. So this is no bueno. I've deleted everything. I didn't actually want to do that. So what do? We can do some cool stuff here, like git reset, add 1. It might not like this. Let's worry about git reset another time. If I had worked on what is called a fork, I could demo the git reset, but let's not worry about that. If this will not have an effect on the Foxtrot repository, because like I said just earlier, I did not actually create this repository on Foxtrot first. I created it on my local, or on my GitHub account, my personal GitHub account. by mistake, Foxtrot evening weekend. Is that what it's called? Foxtrot Platoon EW. Actually, let's look at. Is that clear, by the way? Is that I don't know if that was a lot of information, if I went through the whole Git flow too fast. Give me some feedback here.
I think that was too fast for me.
Right on. We can work on it more one-on-one. That might be a little better. How's that sound?
I think that will be wonderful.
Cool. When we do breakout rooms, I'll be sure to hop into one with you to talk through Git. Same goes with any of the TAs. Feel free to ask any of them, any of us instructors, for one-on-one help when you need it. Let's see, what should we cover now? I'm going to move on. Oh, sorry, go ahead.
I have one quick question about the setting the upstream. Is
Sure.
that just to keep up to date with the original repo?
Yes.
Or is that, yeah, gotcha.
Yeah. And like I said earlier in my example, if you're working on multiple changes, you'll want to stay up to date with the original repo. Plus, you'll also want to have a clean fork that's separate from that source repo so that you'll be prepared to handle any change conflicts or any mistakes that you might run into. Yes, Raymond.
Yeah, just a quick question on branches. If you could kind of just run through what exactly is happening when you create a branch, and then whenever you go to push that, I know that there's some additional commands that you have to put in there, like origin, and then you put like the branch name or something like that. If you could just kind of like explain like functionally what's happening when you create a branch when you're trying to push that branch back up into GitHub.
Sure. Let's hop into, I believe this should be the curriculum, your curriculum, Foxtrot. We get status. I am currently on this branch called week 1, day 2. I've already pushed my changes, so I'm done with this branch. It's good to go. It's clean. I should not make any more changes to this branch unless I was changing this exact same module. Let's say I want to start working on week 1, day 3. I'm going to first go back to the main branch. So git checkout main. I want to make sure that I'm up to speed, up to date with the source repository. So I'm going to run a git fetch. I'm going to fetch from the upstream because I want the updates from the source, not my own fork. So git fetch upstream main. I want it from main. It's fetched all the changes. Or sorry, what's happening here actually is this is not pulling any changes. The fetch is pulling the branch history. So if somebody else made changes and they pushed them, they may have been working on a new branch. They should have been working on a new branch. This is what that's fetching. I'm getting the branch history. Fetch is useful for when you want to get up to speed with changes to a source repository, but you don't want to overwrite your own changes, or you don't want to run the risk of potentially overwriting your own changes. If there was a change conflict, when you do a git pull, you'll be given some options as to the method of polling that you want. It's all going to show up in the command line. There's not an example to use right now, but if that were to happen, you should be able to use the interactive editor to resolve any change and merge conflicts. I had a great example from earlier today. I should have thought ahead and recorded that or something, but we're going to run into it eventually, so we'll be able to cover it eventually. Once I've done my git fetch, if there are changes to the source repository and I do want to pull them into my repository, this is something that you're commonly going to want to do when you're starting a new branch, or if you go back to your main branch so that you know it's up to date. I'm going to do a git pull upstream main. Actually, it is telling me, it is giving me an option. So this is what I was referring to just a second earlier. It's asking me the method of pulling that I want. And this is a lot to try and explain right now. So we're not going to dive too deep into this. This first option is what you're mostly going to want to use. Basically, it's a default strategy. This merges the changes from the source repository into your local fork. This is pretty much like 80% of the time what you're going to want to do. So let me, and we could see here what changes exist in the source compared to mine. There have been changes made to the README.
So are you going to lose? So since you're pulling stuff from the source repository, if you had made changes to it, you're losing your changes?
Yeah, let's do that right now, actually. Let me go into this day 2 README and make some changes to that. So if I were to open up module 01, I'm hitting tab to autocomplete. I believe it's week 1, day 2. And what do I have? My README. Pulling this up right now. I'm going to make some changes. So git status. I could see that my file is now modified. So let me try this git pull and let's see what happens. Again, it's giving me this option. I want to basically copy this. It's telling me that I have these options and that I can pass this into the command line to set this global configuration. So git config is the command for setting your git configurations. Setting the config for pull.rebase to false. Basically, I'm saying I don't want to rebase. I just want to merge. So let me try the pull again. So I think what's happening here is it already did the pull. It did the pull before I made the changes. Are there any other files that were changed? Let's see. There was the README, and then there was the terminal basics cheat sheet. What is that? Or there's the week 1 README too. That was also changed, I guess. Okay. Was that already? Yeah, that was already pulled though. So, okay, it's already made those changes onto my local fork. So basically, when I made my change, there was no conflict because my local fork already reflected the changes from the source. If I had made my change to my file before I pulled, then there would have been a merge conflict. Does that make sense? Raymond?
Oh, sorry, I didn't know that was a question directed to me. Yeah, I believe so, yes.
Cool. Yeah, I mean, so much of GitHub and the Git command line is really just order of operations. Just be mindful of the order in which you're running certain commands. If you forget to run a command, or you run some commands out of order, you'll be able to fix things. It's probably just going to be a headache at first. It really is going to be a headache at first. It's kind of, just think of it as like trial by fire. Nobody enjoys GitHub at first. It really does take a while to get used to, but you'll get there. You will get there through repetition, practice and repetition. So I think, was there anything else I need to cover? I have a new fork, or I'm working on a new fork of I explained the branch, right? Did that cover your entire question, Raymond, or am I missing anything?
I think I just need more practice. So I think we'll just go from here, continue.
Okay, cool. So let me see. I'm going to exit out of this so we could segue back into today's lesson. Fortunately, today's lesson is pretty straightforward. It's just a review of the JavaScript fundamentals that you all have already learned. So let me pull up. Finally back here. By the way, I think I set some time for a break at 6:15. We definitely went over. How do you all feel? Show of hands. Who needs to take a break right now, or should we just power through and get through this in like 10, 15 minutes before you guys take a break?
Push.
Right on. One vote for push. I see some nods. All right, we're pushing. Cool. So somebody tell me, what are 5 to 6 of the most primitive data types? Vincent, since you want to push.
Strings, right? Booleans, numerical. I'm not really sure.
Go on. You're on the right track.
No, that's all I got.
Anyone want to give a few more?
You got int, float, long and short.
Well, in the context of JavaScript, not really to the ints and floats. C#, yes.
I got you. Okay, yeah. Sorry.
Null, number.
Yes, null. And I think there's one more that I think I want to mention.
Undefined?
Yes, perfect. So strings, numbers, booleans, undefined, and null. Strings are self-explanatory. Basically, any series of characters that is rendered within a quote. So even if it's a number, but it's in quotes, it's a string, not a number. Numbers consist of numeric characters that are not enclosed quotations. In languages like C#, there is a distinction between integers and floats. JavaScript does have something called big int. You're rarely going to use it. It's basically scientific notation for numbers that are bigger than what we commonly like work with on a day-to-day basis. Very large numbers, basically. Big int, self-explanatory. Booleans are also pretty self-explanatory. It's true or false values. Undefined and null is where things get a little interesting. They are both empty values. They indicate the absence of a value, but they have very slightly different behaviors. Undefined is assigned by default. Whenever you create a new variable, if you're not assigning any value to it, it is undefined. A use case for this would be, let's say you're testing, you're debugging. You write a function to update a variable. When you're debugging, you look at your console log and you see that the type is still undefined. This tells you that this variable was never modified. Your function failed. If you had a variable that was going to update this to null because maybe you expect this kind of behavior in your application, then if it returns null, then you know your function actually succeeded. Null is useful for situations where you expect the possibility of nothing being returned. Let's say you're hitting a database with a query on a regular basis through like a scheduler or something. Maybe you're not always expecting data to be returned. Maybe if you're only looking for an error, for example, it makes sense in this context to receive a null value, to define your variable as expecting a null value. Why do data types matter? This is a little more open-ended. Let's hear from someone we haven't heard from yet. Sandy.
Sorry, what was the question?
Why do data types matter?
I feel like that's such an open-ended question. I mean, they matter because computers need to be specifically told what to do.
Right on, yeah. No, that's definitely on the right track. Anyone else want to add to that, take a stab or expand on it?
Yeah, I guess like, because obviously if you're using if your function uses numbers, you can't put a string in there. If it's like a loop true or false while loop or something, obviously you need to use a Boolean. So it's just like, it's like having the right tool for the right job or something like that.
Exactly, exactly. You are both correct. It's just about proper communication. It's about controlling the interactions through operations. So operators, which are used to manipulate expressions, they exist as things like simple arithmetic, plus, minus, multiply, divide, etc., modulus, or logical comparisons, greater than, less than, equals to. You can also use operators to increment or decrement values. And you have operators that can modify values. Does any of this look new to anyone here? Awesome, love it. It shouldn't look new. It should have all been covered during the foundational classes. Let's talk about the loose equality versus strict equality. Does anybody want to take a stab at explaining this, like in their own words?
Yeah, I'll do it.
Sure.
So the loose equality, well, the strict equality means that the thing it's comparing to has to be exactly that. So like if you're comparing like a string, like two characters, right? So like an A and an uppercase A, that's going to return false because it's uppercase. But if you use loose, then it's going to return true because they're both A.
Exactly.
I believe.
Exactly.
Yeah.
Well, that's spot on. Loose equality will run some data type conversions, such as in, like, for instance, example, comparing lowercase a to an uppercase a. We also have our logical and or operators. We have the not operator, which could be assigned to things to negate the statement or to really flip it around. So let's take a stab at what these will evaluate to. What will true and not true evaluate to in JavaScript?
That'll be false, I believe, because it's true. It's basically saying true and false. And since one of them is false, then it's going to be false.
Let's take a look. Let's see if that is correct. True and not true. False. You are correct. All right, what's the next one? True and not false. What will this evaluate to?
True.
True.
Nice. I do believe that is correct. Yes. And got one more. True or not false?
True.
Yep. Good to go. Looks like you guys have the basics down. Right on. Give yourselves a pat on the back. All right. What are the two most common collection data types?
Arrays and objects.
Yes, exactly. In some languages, they are also known as lists for arrays or dictionaries for objects. Dictionaries, like in Python. What are the key differences between these types?
Arrays have an index. Objects are key value pairs.
Exactly. That is exactly correct. Arrays are indexed. Objects consist of non-indexed key value pairs. All right. What are conditionals? Or what are some conditionals? Maybe that's a better way of asking the question.
An if statement.
Yes. If, else, and maybe even while expressions. What are some iteration methods?
For statements.
Yes, exactly. For loops. And let's see what else. We are going to recap over these. Data structures. Let's talk about that for a sec. Well, I think you might have covered this as well, and you'll cover this in more detail later on. It's about stacks and queues. What else? Now I skipped this slide because this isn't relevant right now. We could talk about that later. That's even simpler than what we've already covered. Basically, lines of code consist of statements, expressions, and each statement and expression consist of individual characters. let's talk about Node.js versus browser. This is something that will definitely come into play when you are working on your code. Can anyone, even just based off the text here, kind of say in their own words what the differences are between compiling with Node.js and compiling JavaScript code in a browser? Tim
Is
or Jordan?
I was gonna say, is Node.js server side?
Yeah. Yes, definitely. That is, yes, one element of truth to that. Yes. What else?
Well, Node compiles in the Node server, and the browser is compiling in the browser in the DOM.
Exactly. Yes. I don't know if you guys are familiar with Next.js. It's not something that we cover in the curriculum. It's something that we're exploring the possibility of covering, but it is a React framework that allows you to build out both server side and client side functions and components. And maybe one of the other key things to remember here is when you're working on your own code, let's say you're working with some external APIs, you might get a function to run from your terminal because you're running a file in Node.js. But when you call the same API from the browser, you find that it's not returning what you want. It's instead, this is very likely a result of the cross-origin request sharing policy. It's a policy that exists specifically for browsers. It's a security measure to ensure that requests coming from the internet are valid and they are coming from valid sources. So a typical flow for this is, and you'll probably run into this when we get to this part of the curriculum, you need to go to the back end and essentially set up, you need to whitelist the origin and basically say, I want to be able to accept requests from this destination. And so that's probably like the most common thing that you're going to run into in this curriculum in terms of compiling in Node.js versus compiling in the browser. We'll cover that more later on. You guys haven't had a lesson with Chad yet. Has either Jordan or Omar talked about the overall theory behind why this curriculum was designed the way it was? Why you guys go through a full stack application twice, essentially? You learn it with basic JavaScript and Python, and then you learn it again using frameworks. Has anyone really gone into detail over that?
I think they mentioned like you got to understand, like if you use a framework and it does all the work for you, you got to understand kind of what you're doing, so or what it's doing. So if you understand, it's like building a website with those, those applications where you just kind of click and drag what you want and then it writes the code for you. If you don't really understand how it's working, then you can't edit or like find mistakes or something.
Right on. No, exactly. That is exactly it. Yeah, we want to be able to teach you the foundation so that when you go through with the frameworks later on, you understand how the magic is working. Cool. So we have powered through. I believe we pretty much hit everything. These are some general reminders that I like to share before an assessment, but since it's our first class, I'll share it here too. Slow and steady wins the race. If you need to pseudocode, especially in whiteboarding situations, it's very easy to underestimate the kind of anxiety that you'll feel when you're put on the spot. So getting in the habits of slowing down and thinking through your code step by step, breaking anything down to more digestible chunks, that will help you in those kind of situations. Keep your code dry. don't repeat yourself, basically. Try to be as efficient as possible with your code. If you're constantly repeating the same code over and over, that is kind of defeating the purpose of programming. So that's something that you want to get in the habit of being observant of. Let's see. Yeah, we can go over the rest of these in more detail later on. I feel like I have ranted enough. Let's give you guys a break. Take a 10 to 15 minute break. When you guys get back, there will be breakout rooms open for you all to work on your challenges. Sound good? Cool.